Hey guys, welcome to lesson 622 day 1. Today we are going to learn about two new properties of logarithms. They are the addition and subtraction property, but they're also known as the product and quotient property. So first, let's go ahead and take a look at these situations and see what we notice. Okay, when we think of log of 30 versus log of 5 versus log of 6. First, I do want to mention the importance of the fact that 6 times 5, in fact, equals 30. You know, just like the rest of these, 4 times 3 does equal 12. 5 times 2 equals 10. Okay, so as we're going through this, keep that in mind. So we've got log of 30. And when we type in log of 5 plus log of 6, we get the same exact answer that we got when we typed in log of 30. So 1.477. Let's go ahead and write that down for both of them. All right, let's try the next one. We've got log of 12, and then we get 1.079, and then log of 3 plus log of 4. We get the same thing, so 1.079 for both of these. All right, now for this last one, we have ln of 10. ln of 10. And then that versus ln of 5 plus ln of 2. So yeah, natural log of 5 plus natural log of 2. And sure enough, as you probably expected, we got the same exact answer, 2.302. Make sure I rounded that right. 303. All right. So the whole idea here is to notice that when we add two logs consisting of factors that multiply to another number, we have an equivalence, right? These two logs added together is the same thing as this one log with these two numbers multiplied. So that works all the time with logs, right? And that's exactly what the product property is. It's telling us that we can go from multiplication inside of one log, that's why we use the word product, and translate that to the addition of two different logs. Okay, so you can think of this as going between multiplication and addition. All right, it's also important to note that you don't get these mixed up. It doesn't work the other way around, where if you have an addition in the one log, it goes to multiplication of 2. You have to note that it's the multiplication inside one log, translating to addition between multiple logs. Depends on how many things were being multiplied. All right, so one last example here, like if I had the log of 16, right? Log of 16, you guys would probably agree, is equal to, well, let's do a better job writing that. All right, we can rewrite 16 as 8 times 2, right? So if I had that, that would then be the same thing as log of 8 plus the log of 2. And all I did was I took each piece, each factor, and gave it its own log, and I added those two logs. Okay, that's what the product property is saying. Now it also says that I could go backwards. If I had log of 18 plus log of 2, I can work my way up and show that that equals log of 8 times 2, which then is just log of 16. All right, so that's it for the product property. Now let's move on to the next property. But first, we're going to do another investigation. So the log of 90 divided by 3, let's calculate that. Start a new page here. Log of 90 divided by 3, we're just going to type it in just as we see it. And then let's try log of 90 minus log of 3. And we get the same answer for both. Would you look at that? All right, Let's do the next one. Log of 24 divided by 2, oops, versus log of 24 minus the log of 2. All right, and sure enough, I got the same answer, 1.079 for both. Okay, this one I can type in 2. We've got log, well, not log, natural log, so ln of 50 divided by 5 versus ln of 50 minus the ln of 5. And of course, I still get 2.303. All right. So this is the very essence of our next property, the quotient property, which is that if you have two things being divided in a log, that translates to subtracting multiple logs. In the product property, we went from multiplication inside to addition between multiple. In the quotient property, we go from division inside one log and subtraction between multiple logs. Well, between two logs, really. All right, so for another example, if I had log of 16 over 2, this translates to log of 16. The top number always comes first, minus log of 2. Okay, you have to be careful. Make sure you don't flip those. If 16 is on the top, the log of 16 has to come first. If 2 is on the bottom, log of 2 has to come second. Okay, and that is what the quotient property is. Now let's not forget what the power property is, which we already learned, which is just the fact that we can take any exponent inside the parentheses of a log and chuck it to the front of the log, right? And that turns into that number being multiplied by the log. But that one we've already talked about, so I won't go into it too much. So the whole point of these properties, well, a big part of it, is that it gives us the ability to condense and expand logs or log expressions. So when I condense, that means that I can take multiple logs. Like if I had given you something like this, that's 2 logs, right? Anything more than 1 counts as multiple. I can take those and I can condense them to look like this, which only has 1 log in there. Okay, and then that's where this single logarithm idea comes from. If I tell you to write something as a single logarithm, that means condensing. But, you know, you can't always write it as a single logarithm. You just kind of go as far as you can. You fit whatever you can, squeeze whatever you can down. Now, expanding is the opposite. Okay, that's when you take one logarithm and try to expand it as much as you can into as many logs as you can. So that would be going the other way around, right? From log of 90 over 3 to becoming these 2 logs. I like spread it out as much as possible. So we're going to go over some examples of doing that. All right, so here I have some problems where I am being asked to condense these logs, okay? I am asking you to write them as a single logarithm. So here, I notice that there's subtraction between 2 logs. So I'm gonna go back and be like, okay, well, which property can I use to help me condense this? I notice that here in the quotient property is where I'm working with subtraction. So from subtraction between 2 logs, I can turn it into division inside of 1. So this means that, I'm going to switch colors, I'm kind of bored of that other color now. I can say that this is the same as log base 3 of b over 6. Okay, and I do want to take this time to note that this rule only works, both of these rules that we learned only work when these bases are matching. If the bases didn't match, they would not work. Okay, I can't do this if I had like a 4 here. It just is not valid anymore. Okay, but here we are good to go. This is it. I've condensed it into just one logarithm. So the next one, and actually let me just note that I used the quotient rule. The next one, I have addition going on between two logs. So let's go back to our notes and figure out what to do. So I noticed some addition here, and I see that when we have addition between multiple logs, we can go to multiplication inside of one. So using the product rule, I can say that this is the same thing as log base 4 of y times 3. Now I can very well just rewrite this as 3y. I prefer it that way. You don't have to. If you wrote something like this, I would totally accept it. Right, and that's it. I've condensed it as far as I can. Okay, one more condensing example here. We've got a little bit more going on here though. So the first thing I want to notice is that there's actually numbers outside of these logs. Okay, and if you remember where that comes from, let's look back at our notes. The power property is what does that, right? If there's a number in front of a log, that means it originally could have been an exponent inside of the log. And when we condense logarithms, we like exponents. We don't want them to be sitting outside. We actually want to bring them back. All right, so now this is the opposite of what we did with power property before. Before, we checked the exponent to the back seat, right? And now we're taking it and we're bringing it back to the front, inside. So I can rewrite this as log base 4 of b to the 7th plus log base 4 of c to the 4th. All I did was I brought these exponents back and made them into exponents. But here's the thing, I'm not fully condensed yet. There's more that I can do. I noticed that there's some addition going on here, so just like this last problem, I can use the product rule to take care of that. I can say that this is also equivalent to b to the 7th times c to the 4th, because product rule tells me that if I have addition between two logs, I can just multiply those and turn it into 1. So it's important to note here that first we used the power rule, and then we used the product rule. Okay, and then this is as far as I can condense it. So I am done with that problem. All right, so let's do some expansion examples. So here we have multiplication going on. So it's kind of like the opposite of this, right? When we have multiplication, we can go to addition. So because we're expanding, this is expanding, we want multiple logs. So this can be rewritten as log base 5 of a plus log base 5 of e. Whatever I have in here, if they're being multiplied, I can just split them, give them their own logs, and add them. All right, so this one got a log and this one got a log. And that one is done. That's as far as I can expand. For this one, I see division. So division, and let me write this. This is, I used product rule here. Here, I can use quotient rule and say that, okay, well, if there's division inside my log, that turns into subtraction of two logs. Okay, and again, a scenario where each one gets its own log, but this time it's subtraction instead of addition. It makes sense, right? Multiplication turned to addition, so the opposites apply. Division turns into subtraction. So our last one here, this is the more complicated one. It has a little bit more going on, right? There's some exponents, so don't forget about that. The first thing we want to do is rewrite this as two different logs. We can say that using the product rule, we can split those up into addition. And there are also exponents. So we want to use the power rule to chuck those to the back seat, because when we're expanding, we don't like exponents. When we're condensing, we like exponents. When we're expanding, we don't like exponents. So I will rewrite it like this. Oh, I forgot my base. Okay, and this is the farthest I can expand it. Here I used power rule, and then here I used product rule. Okay, and we're done.